Okay, so what we were doing on Tuesday, we had this, right? So we wrote a little program to ask the user to enter the radius of a circle, right? And then based on that radius, we did some calculations, and then we did some basic output to the screen. Okay. So here at the top, we had a block of comments. We had a constant for pi that we declared. Inside of the main function, we declared some variables. We got the input from the keyboard. Then we did some calculations. We also watched out for integer division on the 4/3 for the sphere volume. And then we outputted some stuff to the screen, and it looked like this when we compiled and ran that. So enter the radius of a circle, type in a radius, and we get something like that, right? So let's notice a few things about it. So it outputs 6, 12. And then notice on the other things, it goes out to a certain number of decimal places, but it's not really consistent. One thing I think about the dev C++ compiler, I think it's got some different default settings. Like yours might automatically go out to a certain number of decimal places, okay? But that's not always consistent between compilers there, because notice mine doesn't show any trailing zeros when it's a whole number, right? Trailing zeros, in other words, it doesn't say like radius is 6.0000 or something like that. And then on the other things, on some things it went to 4 decimal places on the output, some things went to 3 decimal places, and so forth. And also, what happens if anybody try to type in a really big number? Notice what happens when we type in a really big number. We start getting this e to the whatever power thing going on. That's scientific notation, okay? So that means 7.76554 times 10 to the 14th power is what that means. So at some point in time, when the number gets to a certain size, by default, it kicks into scientific notation. Okay? But there's ways to control all of that, and so that's what I want to show you today. I want to show you how to do some output formatting, so that you can have more control over how things look on your output. And you'll have to do things like this on your first programming assignment as well. So I think I can make that output bigger as well. Let me see if I remember how to do this on the output screen. Let's try that. There, that's bigger. Okay. So to do some of this stuff, we have to know about some output manipulators. Okay, so these are some of the things that we're going to talk about today. We're going to talk about this thing called setprecision. Okay, there's something called setprecision that we're going to do. There's something called setw, or set width is what that stands for. And then we might want to control if things are left aligned or right aligned. So there's a couple of manipulators that control if things are left or right aligned. So, and keep in mind, this is not a word processor that we're dealing with here, right? This is not simply just, oh, I need to left align something or right align something, I'll click on a button and it'll do it. That's not this is a totally different world, right? So if we want something to look a certain way, we have to specify with some instructions on that we want it to look a certain way. Okay. So there's set precision, set width, left and right. I'll show you what these things are: fixed and showpoint. Okay, and there's a header file that we'll need for some of this stuff, and it is IO manip, IO input output manipulation. So we'll have to end up adding that to our header files. Okay. So keep that in mind. These are things we're going to cover. So first thing let's talk about is maybe this this decimal thing and the scientific notation thing that we have going on. And like I said, on yours, if you're using the dev C++ compiler, it might automatically show to a certain number of decimal places. But obviously mine didn't, so that can differ based on compiler. So let's go down here. Go down to right before you output your results. Actually, I'm just going to do a little section here. And I'm going to put a comment here. I'm going to say set up some output formatting. Okay. Set up some output formatting. And so, like I said, the first thing, just a reminder how it looks. Notice on mine at least, and this is how code blocks outputs apparently. If I output a whole number, like 5, or if I input a whole number, right, for the radius, on my output it just shows 5, and for the diameter it just shows 10. So it doesn't show what we call trailing zeros. Trailing zeros are zeros that come after that, like on the decimal places, and it doesn't show the decimal point either. Okay. All right. So how would you control that to make it show the decimal place? Well, here's how you do it. You put in a command cout, and you say showpoint. Okay. Cout and then showpoint. And what that does, it tells the compiler to show that decimal point. Let's see what happens when we do that now. So now if I type a 5, hey, it looks different, doesn't it? So now it shows that decimal place automatically. So now when I type in 5 for the radius, I get 5.00000 or whatever, right? So that's what that does. It forces it to show that decimal place and some trailing zeros. Okay. Now, that still doesn't fix this scientific notation thing. So again, if we put in a big number, oops, didn't mean to type E. If we type in a big number, then it will automatically kick in the scientific notation. So if you don't want that, if you always want it to be in fixed notation is just, it's going to show all the digits. You can do that. And so I'll do that on, you can do that on a separate line or in the same line here. It doesn't matter. I'll make a comment here. Show decimal point and trailing zeros. To put it in fixed notation, you just say cout insertion operator fixed. And again, you can chain these things together. You could say, and in fact, I do that a lot of times. I'll say cout insertion operator fixed, another insertion operator show point. I'll do those two things on the same line usually. Put output into fixed notation. Okay. If you want things to always be in scientific notation, if you want everything to be in scientific, you would just do the same thing, but you'd say instead of cout fixed, you'd say cout scientific, and it would output everything into scientific notation, even if it's a small number. So cout fixed. So let's see what happens now when I do that. So now, if I type in a big number, like I did, it doesn't it doesn't go into scientific notation anymore. It stays in fixed notation. Okay. And it looks like now it's outputting to what, 6 decimal places. So I wonder if that kind of changed some kind of default or something. So let's talk about how to control how many decimal places it outputs to. Okay, so we can do that. Suppose we wanted to output everything to 3 decimal places. Well, there's a manipulator called setprecision that we can use for that. So I'll do that here next. We say cout insertion operator setprecision, all one word, and then inside of parentheses an integer number telling it how many decimal places to output to. And don't forget your semicolon. So cout setprecision 3 is going to tell the compiler output from this point on, output all my floating point results or all my floating point numbers to 3 decimal places. Okay. And now it's not going to change what's stored inside the computer's memory for those numbers, but it will change what gets output, and it will round. Okay. But again, it's not changing what's actually stored there. So the full, if it goes out to 10 digits, 10 decimal places inside the computer's memory, it's still going to stay there. It will just get output. If I output it, it will only get output to 3 decimal places. And so setprecision will stay in effect until you change it. So if later on you suppose you wanted some numbers to be set to 3 decimal places on the output, you use setprecision 3, then output those values or whatever. But then later, if you want to change that, maybe you're outputting some money or something like that, some money numbers, and you want to change the precision to 2 decimal places, you just put in another statement at that point in time saying cout setprecision to 2, and then from that point on, it will output to 2 decimal places. Okay. So let's test it. So what happens now? So do you get an error on that?
Yeah.
So it gives us an error at that point in time now, and it will say something. The error probably says something about, I don't know what setprecision is. Setprecision was not declared in this scope, okay? And that is because the code for setprecision that allows that to work is inside of a header file that we haven't included. So the name of that header file is iomanip. It's this one, IOMANIP, input-output manipulation. So what we need to do is go up to the top of your program, and where you have your other header file there, your include file, number include iostream, right underneath that, let's add this one. Number include iomanip. IOMANIP. So you add that up to the top.
IOMANIP.
Yeah, IOMANIP. And so now when you compile and run that, it should know what setprecision is now. And so now it outputs in fixed notation to 3 decimal places. And so everything there is to 3 decimal places, right? Make sense? I just remembered there was one thing that I was going to show you last time that I forgot to show you. I guess we ran out of time. And that was the power function, right? So let's do that real quick. This is not an output formatting thing, but I meant to show it to you last time. So if you go back to your calculations, we had the area, for example, was equal to pi times radius, or radius squared, right? And the sphere volume was 4/3 times pi times radius times radius times radius, radius cubed. So that's not that much to type when we're only talking about squaring or cubing something, but again, what if it was like radius to the 100th power or something like that? That would be a big pain to type times radius, 100 times. So in C++ does not have a built-in operator that will raise the base to an exponent like the caret sign does in some languages, but it does have this thing called the power function. And the power function is just a math function that you can use to raise a base to an exponent. So let me show you how to do that. So go back to your calculations and let's replace three things. Go back to the area where you say area is equal to pi times radius, and change that to this. Area is equal to pi times POW, all lowercase, and then inside of parentheses, radius, comma, 2, like that. So that means radius to the second power. And the same thing on the sphere surface area. Let's change that to 4 times pi times pow, and then inside of parentheses, radius, comma, 2. And then on the sphere volume, let's do 4.0 divided by 3.0 times pi times pow, radius, comma, 3. Radius to the third power. And so now when you go to compile that, you might get an error now. You get a new error. Yeah. So it gets down to that first time that you use the power function, and it gives you an error on that saying that POW was not declared in this scope. So it's a similar type of thing that we just saw with not having the right header file. So now we need to go back and add another header file to our includes that's CMath. So go back up to the top and just somewhere we can put it, this is the next one. We want to add this line, number include, in this side of angle brackets, CMath. Sorry, like that. It's the old math library from the C language. Okay? It used to be called like math.h, I think, but now we call it CMath. So CMath has all kinds of built-in math functions. It's really useful for a lot of things. I think it even has a built-in constant for pi that you can use, but we got some good practice declaring and defining our own. So add number include CMath up there to the top. Now when you go to compile and run, it should know what the power function is now. And it should do exactly the same thing that it has been doing. Make sense? So how's that going? Everybody good so far? Yeah. Cool. Yeah. Good deal. All right. Are we ready to do something else here? So getting back to this output formatting stuff, here's what our output looks like at this point. Let's just put in maybe a number about that size. Okay. And so we talked about how to put it into fixed notation, how to output to a certain number of decimal places, right? But what if we wanted to do something like get things to line up? Like maybe we want our text on the left, you know, our label like radius, diameter, circumference, and all that stuff. Maybe we want that to line up on the left-hand side, and then, you know, maybe to left align, and then over for our numbers, maybe we'd like to have those right align. That's a common thing to do, right? So we want to right align our numbers so that the decimal places all line up and stuff. So to do this, there might be a little trial and error involved with this process, but I'll try to give you some pointers on how I would go about doing this. Okay, and so in order to do this, we have to use something called a set width or setw. We'll also have to make use of the left and right manipulators. Right? C++ doesn't have a center; it's just left or right. Okay. So what set width or setw does, it will output whatever you output next in a certain field width. And field width meaning the number of characters on the output screen that it's going to take up. Okay, and so set width only affects the very next thing that you output. Right? So if you say cout setw 15, and the next thing that you output is something like the word radius, it's going to output radius in a field width of 15, right? Or whatever you have inside those double quotes. And by default, things are going to be right aligned. Okay, that's how it does it in C++. By default, things are right aligned. So let me show you. Let's see that in action. So to do this, I'm going to go back in here, and I'm going to take out the colon space on each one of these things. Like that. So there's no colon space anymore on my output lines. And so up here, just for example, on this first line where I say cout radius, I'm going to say cout, insertion operator, setw, and then, I don't know, something like 10. And then you have another insertion operator and radius and so forth. Okay. So let's just see what that does. Okay. So notice now on our output line, radius kind of goes over to the right a little bit, doesn't it? And so it actually takes up 10 characters. And by default, any extra characters that are in there are spaces. Okay, I can show you how to change the fill character later, but they're by default they're spaces, and by default things are right aligned. So if you were to count up these spaces, we can just look at the line underneath there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it takes up 10 spots. If we were to change that to 25, it would take up 25 places, right? We'd have a whole lot of extra spaces before. Okay. All right. So we're going to use this to get all of our stuff to line up. So let's focus on the text stuff first. Okay. Now, whenever I'm going to do something like this, what I would suggest doing is so you've got all these different lines, radius, diameter, circumference, and so forth, that you want to take up the same amount of field width, right? So what you should do is look down through all those and find the longest line. Which one of those has the most letters in it? Sphere surface area, right? And so I would count up all the characters in there, including the spaces. They count as spots, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So your surface area is going to take up 19 characters on our output screen. So I would go with at least 19. I'd maybe suggest 20. That's just a nice round number there. So C out, set width 20, okay? It's going to take up 20 spots. And so we're going to do this on every one of these lines. And we do have copy and paste that we can make use of. So I would suggest that. So I'm just going to copy this first part here, this insertion operator, set width 20. And I'll just come down here to each of these lines. And do that. And you want them to be the same, at least for this application. You want them to be the same because you want them all to line up and take up the same number of spots, okay? Because what we're going to do after that is we're going to have some numbers, okay? And if you don't make this consistent, then that's going to affect how all your numbers are lined up and stuff like that. So that's what we get at this point. So all of our text is lined up in the same field width of 20, but it's right aligned, right? We probably don't want that. We probably want it left aligned, lined up to the left. Okay? So that's where this left manipulator comes in. So before that, and by default, things are right aligned. If you don't want it right aligned, you can do this. You put the word left in there. So like on that first line, I say C out, left, and then set width 20, radius, and so forth, like that. The left and right manipulators, those stay in effect until you change them. So once I change it to left here, everything from that point on is going to be left aligned. So there you go. So now all my text is left aligned in a field width of 20, okay? Which is all great, except I didn't want my numbers to be left aligned, right? I want my numbers to be right aligned so that that decimal place lines up. So that kind of complicates things a little bit. But is everybody cool with that so far? I didn't know what you mean. Yours didn't left align? So let me go look. All right, so how about these numbers, right? So maybe we want the numbers to be right aligned, okay? So if there's a left, there's probably a right. So that's what we want to do over here. So after you output the word radius, you want to change it to right aligned. So now add this to line where the first line where you output the radius. So C out left, set width 20, the radius, and then change the alignment to right. And then output the radius. Okay. So let's see what that does. So now I type in a 5. Well, that doesn't help that much, right? In fact, what did that do? So that now, once I changed the alignment to right, again, left and right, they stay into effect once you change those. So now my text underneath there is now right aligned again. Okay, so and also my numbers, that's not going to help me that much. Left and right, when I use these, it's not going to do much for me unless I use it inside of a set width, field width. Okay, so here's what you need to do. So after you right align it there, let's add another field width. We say setw. And as far as the size for the numbers go, this is kind of a, you have to kind of make a judgment call here, an estimate. You kind of think to yourself, okay, how big are my numbers probably going to be? How many digits? And of course with decimal numbers, that's a little bit even more uncertain. Of course, we know that we're outputting to 3 decimal places now because we set that, right? So as far as like the number of characters go, we know we're going to have at least 4 because the decimal counts as one of them as well. So point and then the 3 decimal places, those are 4 characters. And then however big the whole number part is, how many digits that is, will count in the field width as well. So let's go with something like 25, okay? And see what that does. So see out left and then field width of 20 for the text, then change it to right, and in a field width of 25, output the radius. Okay. All right, so this is what we get now. The radius is over there on the left. It actually is in a field width of 20, right? The field width stops here. And then from then on, we have 25. Now you might think, well, that's a lot of space there, but it also leaves the option if we have a larger number, that's going to take up more digits or more characters, right? Oops. Like that. So there, we've got the text left aligned, we got the number over on the right in a certain field width. What about the other stuff, right? So what we're going to have to do, for this situation at least, is we're going to have to do this same thing on every line. But luckily, again, we have copy and paste. So on every line, you're going to have to say left, and then in the field width of 20, output the text, and then change it to right, and in a field width of 25, output the number. Okay? And that's what you want to do, and you want to be consistent with the field width sizes because you want everything to get lined up. So again, I would just make use of copy and paste here. And so on every line, we're going to add left, left, left. And then over here, go ahead and grab the right and set width 25. So usually Control C does copy and Control V is paste. Like that. So it's the same thing on every line. And so let's see what that does for us. Cool. So now things are left aligned, the numbers are right aligned, right? And yes, there is a little bit of space in between, but that's okay. I mean, that leaves the option if it's a larger number, that sphere volume is going to get kind of big, right, as far as the number of digits that it takes up. And so you might wonder, okay, what happens if that set width for the number is not big enough? Well, anytime you set width and set the field width to a certain size and then output something that takes up more characters or more spots than that, it's going to bust out of the field width. It's going to take up as many characters as it needs. So that's why you need to kind of think about how big this field width needs to be and make sure that your field width is plenty big for what your application is. So just to give you an example, again, if I put a really big number, that field width wasn't big enough, right? But I'm going to decide that we're not measuring the radius of a planet or something like that here. We're just talking about smaller numbers. So I'm going to determine that, or decide that, hey, that's not a realistic number for the radius for this particular program. And if we wanted to put any kind of label on top, we could do that as well, right? With just a couple of cout statements. So what if I wanted, so I know that's going to take up what, 45 total characters, right? 20 plus the 25 for the numbers. So what if I wanted to output some asterisks on top or something like that? I could do something like this. So this is one way I could do it. And maybe output some kind of label that says program results or something. And I'm just estimating the number of asterisks, but I can go back and adjust that. So I have too many asterisks, right? So I might need to get rid of like one, if I want it to line up with the digits, 1, 2, 4, 5, 6, 7, 8, 9. Need to get rid of about 9 of them. Maybe center this. Actually, that's pretty good. So there you go. If I wanted to have like maybe a blank line or two up above the program results, I could just throw in a couple of indels like this. So now there's a little bit of separation there. Same thing for after it if you want to have a couple of blank lines after. Just throw those down there. So there you go. Let me show you one other thing that's kind of cool. You don't have to do this, but I think it's worth showing. So we said, like with set width, it outputs in a certain field width, and by default, any extra spaces or extra characters that are in the field width that aren't needed by what you output, by default they're spaces, right? So it puts extra spaces in there, right? Well, that's called the fill character, and you can actually change what the fill character is. And there's another little function called setfill. That you can use to change the fill character. So check this out. Again, you don't have to do this, but I think it's worth showing. Suppose here, instead of outputting kind of like the manual way of just outputting a whole bunch of asterisks there. You could do something like this. You could say, you could just output maybe 1 asterisk. And then up before that, you could do a cout setfill, and then inside of parentheses and single quotes, not double quotes, but single quotes, you can change what the fill character is. So I could change that to the asterisk if I wanted to. So cout setfill, and then change to the asterisk, and then come down here, the next line, and output 1 asterisk in a field width of 45, because I got 45 spots that it's going to take up next. So I'll put 1 asterisk in a field width of 45, and because I changed the fill character to the asterisk, all the extra spots in there are going to be asterisks. Of course, that's going to affect things later down the road, so let's see what happens. So notice on that first line of asterisks, it output 1 asterisk in a field width of 45, but all the extra characters in there were asterisks because I changed the fill character. Of course, that messes things up later when I output my radius and my numbers, right? Because that fill character is still the asterisk down there. So when you change the fill character with setfill, it's gonna change it until you change it to something else. But we can change it to the space if we want to. We can do the same thing here to get that second line of asterisks. Like that. So that will output those headings and stuff. And then before we start outputting all the radius and all that stuff, just do another cout setfill, and then inside of parentheses and single quotes, put a space. And it'll change it back to the space. So there you go. So we changed the fill character to the asterisk, output 1 asterisk in a field width of 45. So there's 1 asterisk that we actually outputted, which is probably this one. And all the others, extra ones, spots are asterisks. And then when we went down here, I changed the fill character back to the space. And so all these are spaces now. So anyway, I thought that was kind of cool. What do you think? Of course, you can always just output a line of asterisks like we did first. And that works just fine. So what do you think? I think that's everything in there that I was gonna show. So there, and all this stuff is from chapter 3, I believe. All the output formatting stuff. So we talked about setfill, we talked about setprecision, set width or setw, and the left and right manipulators. And fixed as well, fixed and showpoint. Anybody have any questions about any of that? Okay, I'm gonna stop this video.